welcome to another adventure in old code. We're going to take a look at something called Mathprac today. One of my programs obviously having to do with math. We'll see if it's exciting. Who knows? I think it was, yeah. It's actually part of the dumb folder. And yeah, we'll see what this is. All right, I think this is the first, let's looking at this now. This is the first time I attempted something like this. I don't know. Well, let's see what it is. There's a sequence of programs that are coming up, and this might start it. I'm not sure yet. That still continues on to this day, actually. It's evolved much beyond what it originally was. But let's see if this is indeed what starts it off. Okay. So we've got addition, subtraction, multiplication, division, and random. Ooh, okay. I'm guessing I hit A for addition. 71 plus 1, 72. Enter. Correct. Yes. Well, that's 100. $70 plus 30 is 100, and it says I got one right by. What? 108. Okay, what's going on? Surely I'm not that bad. This is 103. Oh, come on! Let's try the subtraction. Okay, well that's definitely 60. Correct. 22. Correct. Something's wrong with the addition. That's 37. Correct. Awesome. 3. 81 minus 78. Okay, something is wrong. I'm assuming the multiply and divide will be the same thing. Well, let's have a look. Multiply. Okay, that's 52. Oh, come. I must be hitting something wrong. Division. Sweet. 2. Correct. 16. Correct. 21. Correct. See, I'm good at division. Apparently not. Just for the record, all of my answers were correct. I don't know what this program thinks it wants to do. And of course, then there's random. Random. You know what? I'm betting it has something to do with hitting enter at the end of my... Let's figure it out. Okay, subtract, add, multiply, divide, and ending. Dim shared x. Because of course, why not? Of course, we need a global variable called x. Random number generator, randomize timer, clear the screen, print everything, and ask for keyboard input. It just... Okay, if you pressed A, x equals x plus 1, do add, then sleep, and go back to the do. So this is 4 lines. 1, 2, 3, 4, 5 lines actually. Well, 6 if you count the case, all joined on one line with colons. So this is the do. We do this stuff forever. Add 1 to x, run the add subroutine, wait for a second, and then go back. Okay, so I certainly was doing that, and it wasn't working for me. How big is this? There's not much. Let's do the entire main subroutine before we get into the nitty-gritty details. Okay, so clearly x is going to contain the number of answers you have provided, or the question number. Okay, subtract, multiply, divide. If we chose R, then, and this is pretty much the exact same thing. Add 1 to x. Clearing the screen, choosing a random number between 1 and 4, and then doing whatever that is. Add, subtract, multiply, or divide. Followed by a sleeping for 1 second. So not different really than the other 4. Just randomly selects one of them, and that's it. Okay. So everything else is done in the other subroutines. So let's figure out why I couldn't add anything. I was clearly giving it the right number. Okay, clearing the screen. Num string equals empty string, var1 and var2. I guess these are going to be the two numbers that are going to be added together. Printing them on the screen. You'll recall that when I do a semicolon, QBasic automatically puts a space in between at the end of the variable. So that's why we don't have a space surrounding our plus sign, because those semicolons are going to do it for us. Okay, print this plus this. Timer on. So this must be why, one of the reasons why I wasn't doing very well. It looks like there's a timer. Okay, time equals timer, and I'm pretty sure that's not even necessary. We've talked about that before. I really didn't know what that timer was. I just used it that way. But timer itself gives a current number of seconds the computer's been up and running. So that gets treated as the starting time. Okay, then we start our do. We wait for keyboard input. Okay. So I could have just used an input statement. You know, was 70 plus 30? Well, let's do that. You know, if I did something like this, 70 plus 30 equals, and then I input into my answer, and then if answer equals 100, then print yes, you are awesome, else print you suck, and if, we'll clear the screen. Okay, so this is like in its entirety. Of course, a few things, you get a question mark. We didn't really want a question mark. And you also get all the time in the world. I could stay here for 12 hours thinking about what this answer is, but I clearly did not want to give you an infinite amount of time. I only wanted you to have a certain amount of time. And so because of that, I needed to calculate how long you were waiting around thinking about what 70 plus 30 is. And so I had to recreate the input statement, which we've seen before. I'm not going to get into. Okay. Yes, you are awesome. Okay. We won't go into the details of how to do that, but this is it. We wait for keyboard input. And again, if it's not enter, and it's not backspace, that's what CHR string 8 is, then num string, which is the representation of our number on the screen, gets appended to it whatever key we pressed. If we hit backspace, then we do this funky stuff where we erase the last character. And I've done this before. I've had other dumb programs, simple little things where we've experimented with the backspace. And so I'm not going to get into how that all works. You can look at previous episodes for that. Literally, I think it was called backspace without the A. Okay, so we get our input. But notice this is not a do. We don't wait around for keyboard input. We just are constantly chugging away. And if we hit a key, then we take this action. And we're basically looping until we hit enter. However, if the current time minus the starting time is greater than or equal to 5, then go to the ending. So we have 5 seconds to enter our answer. And the ending says you got, now x minus 1, right? Why x minus 1? Because we increased x before we inputted our answer. So the number of correct answers we gave is 1 less than x. So I made x a global variable. Ugh. So I could print it in this one-line subroutine. All right. So you only have 5 seconds to answer. We loop until we hit enter. Okay. So if the value, remember the value command takes a string and turns it into a number. Returns the numeric value of a string of digits. So just taking what the number we've typed in and checking to make sure if it is indeed equal to var1 plus var2, then print correct. If it's not equal to var1 plus var2, then print incorrect. Followed by an ending, which is... The reason I'm having trouble is usually... See, there's no end if here. Let's look at the subtract for a second. It's the same thing. What was I doing well on? The division. Okay. So I don't know why some computer programming languages, if you have an if statement, it will only take the next line. So if this is true, then print this. Is this actually part of the if statement? Or is it part of the is it just part of regular flow? Because this can be like that. Should be the same thing. Yeah. And that's why I'm not getting anywhere. $87. You got 0 right. Okay, but if I bring it up to this line, technically this is no different. Whoops, let's see. Whoops, whoops. 127. So the problem here, see, I just waited. I can't get past that, and the reason is because what I really wanted this to be, if then print this, do the ending, end if. Is that going to work? $146. Was I not fast enough? So I think that ending was running regardless of whether I got it right or not. I should have wrapped it in an if statement, a multi-line if statement complete with an end if. That is actually a rookie mistake for sure. Let's try and get a lot here. See, now I'm awesome. 86. Certainly 83. Okay, so this works. Oop, there's a backspace. Got 6 right. Okay, let's go back to subtract now. See, the problem is sometimes I did get it right. And the other issue is oh, wait a second. The other thing that's different in subtract is it has a sleep 1 at the end. Now, a sleep 1 sleeps for 1 second or until you hit a button. Now, if you recall, out here in the main subroutine, we also sleep for 1. So in the case of subtraction, we are doing the subtract. If we got the answer right, then it's correct. Sleeping for 1 time, but I was hitting a button, and then it was sleeping again because it would kick out into his main routine. Sleeping again. I don't know, something's a bit funky going on. Let us fix this though. The other thing is this could have been an if-else. So, because clearly you're never going to be both right and wrong at the same time. Let's make sure subtract is fixed now. 26, correct. That's 73, correct. That's 10, correct. Okay, awesome. 2, yeah. Okay, so that fixes things. Good. Let's go to multiply, which is the same thing. No, it's actually not. Sorry, the add, the 2 operands are between 1 and 100. For the subtraction, what we're going to do is, yes, they're both going to be between 1 and 100, but for a subtraction question, it's kind of nice if the first number is bigger than the second number so that the answer isn't negative. And so that's what I did here. I looped until the first number was bigger or equal to the second number. Just making sure to sanitize the answer or the question. Let's do multiply. So for multiply, I decided I didn't want anything more than 15 times 10. I guess that was the limits of my knowledge, and I didn't want to feel like a scum. Not a scum, an idiot. You don't want to get beaten by your own program, so find out your own limitations and make that the maximum the program will give you. Okay, so multiplication, that's awesome. Yes. Yes. Give me another hard one. Okay. Ooh, nice. Oh, I almost did. Oh well. I guess I ran out of time. Or maybe that was the incorrect answer. Who knows? Okay, let's go to divide. Divide is the same thing here. Of course, dividing is a bit interesting because you're going to have decimal answers if you're not careful. So I think in this one, I did make others where you were supposed to give to the nearest thousandth, but not this one. So this one, the first number is a random number between 1 and 100. The second number is a random number between 1 and 100, but anything divided by 1 is itself, and I figured that was too easy a question, and so the second number is not allowed to be 1. And then we're going to loop until until the second number goes into the first number evenly. And it's not itself. So no 16 divided by 16 equals 1. That's too easy. And so the first number is always going to be a nice multiple of the second number. So there are no decimals in any answers. Okay, and then we print the 2 on the screen, and same thing. This goes, yep. And so our division, correct, nice. Oh, whoops. Yeah, that was totally wrong. 8, 31, 9, 14, 3, something is just dawning on me. I kept assuming that I wasn't getting the right answer. I was getting the right answer, but the computer, for some reason, this if statement was doing something wrong and calculating it incorrectly. Not so. Not so. Look at this. In each one of these subroutines, we start the timer, and if it's greater than 5, then go to the ending. You don't get 5 seconds per question. You get 5 seconds in total. How many can you answer in 5 seconds? And that's the reason. So, all this stuff here I did with the ifs and the end if probably didn't matter at all. QBasic can probably do the multi-line if statement, which is unfortunate. X equals 10. If x equals 10, then print. This is printing. Does this print too? What about this? Oh, print. These are all statements that don't. Okay. Now if I do x equals 11, this will always print. I should really clear the screen. Okay, so that is true. Anything tacked on to the same line as an if statement is part of that if statement. And you can have multi-line if statements jam-packed on one line without an end if. That is different from modern computing. Okay, well, good to know. So, you're given 5 seconds. Answer as many as you can. And oh, the random. Oh no, the random was the same as everything else. So, how much can I go? And go. I only got one right. Random, go. No, it's 54. Phew. Oh gosh, 52. Ha. 51. 56. Huh. No. Why was I getting so many? Now I feel like an idiot. You do get 5 seconds per question. Why can't I figure why does this program not run like it's supposed to? Problem is it runs exactly like it's supposed to. And I keep thinking I understand it, when really I have no idea what it is. I'm sorry, folks, for being kind of an idiot. Kind of an idiot who thinks he knows what's going on, when clearly I don't. I better stop now before I put my foot in my mouth anymore. So why was I being kicked out of the game when I clearly got the right answer, and clearly I didn't wait more than 5 seconds? Let's put up the timer. So I'm going to locate 1, 20, and we're going to print timer minus time. Okay, so we're going to print the time left. How come I wasn't seeing it? What is going on? There we go. See, it was less than 5. Oh, right. It's only in divide. Okay, let's only do divide now. Okay, let's do division. It's always there. Whoops. Oh. I feel like everything's gonna work now. What is that? No, of course not. Okay, everything seems to be fine. The division is working like it should. I don't know what's going on. What? I wasn't at 5. Thank you very much. Look at the timer. It's not 5 yet. I'm going to wait. Okay, well, I'm just going to end it there. This is a long time to spend on Mathprac, but thanks for joining me in this adventure in old code. Yeah. Anyway, so is this actually part of the all those programs that came in a sequence? Yes, it is. It doesn't look like it, but it is. And so I do something else with this that's really fun. And I can't wait to get to it, but I think it's going to be a long time before we get to it. Anyway, okay, thanks for joining me. Have a nice day, and we will see you next time. All right, hey folks, I went and committed the cardinal sin of Adventures in Old Code once again. I was about to publish something that had some questions at the end of it. Craziness. Anyway, a lot of time has passed since I actually recorded the first part of this video, and I need to go back and figure this out for myself. So just for my own sake, because you just watched it, but I have to remind myself what was going on. This is what was going on. I was doing addition, and I was saying 136, and it says I got 0 right. Bye. And I had some ideas about why that might be happening, and it turns out they're all wrong. So I want to figure this out, because that's what we do in Adventures in Old Code. So let's focus on the addition. In fact, actually the thing is, if we do division, correct 4, correct 11, correct 4, correct 17, So the division seems to be working. And you know, maybe something is bonkers here. But the addition seems to be totally broken. 149. You know what? I can add, okay? I can add, and I know. Okay, so that's my issue. The addition is totally bonkers. The division seems okay. Let's try the multiplication. So the multiplication's borked as well. 4 is correct. 42 is correct. 88 is correct. 11, that's correct. Well, maybe not. Maybe this isn't borked. 136. 9 times 14 is 126. Whoops. So that actually... So the multiply does seem to work. We'll try the subtraction. The subtraction... See, those are hard. Subtraction is not always easy. So what I want... Okay. Hold on. Let's do this. So for subtract, I'm going to make myself really dumb. Now let's start doing it. That's 2. I know that for a fact. 9. 3. Alright. We'll use the subtract because we made it dumber, and let's figure this out. This is what happens when you do something and you just assume you understand what's going on. So, yeah. If what we're going to do, there are 2 things that happen after you press enter. You're either going to print correct or you're going to print incorrect. And so what we're going to do is we're going to turn these into your standard if statements. And I think we did this last time, but let's just see it working. Or see rather that it doesn't work. Okay, so it doesn't work there. You got one right. Bye. That's fine. Okay. We're going to put some breakpoints only if it's incorrect. Okay? So we're just going to do... It's going to break out of the program if we got the answer wrong, and then the program will stop and we can investigate the variables and what's going on, because it is coming into this if statement when it is not supposed to. Now, why? What's going on? We'll go to... subtraction. Okay, that's 3. Now, 4 minus 1 is indeed 3. But it says it's not 3. So let's investigate going into the immediate window. First, we're going to print var1, and that's 4. Then we're going to print var2, and that's 1. Then we're going to print var... minus var1 minus var2. So QBasic does know how to do subtraction. Now, this is where it happens. What is numstring? It's 3. So, now we're going to print the val of numstring. Thank you, QBasic. We've seen this way in the past before, where an integer is represented as 2.99999. Anyway, it shouldn't be. Internally in the memory, this is funky stuff going on. So I've never been able to pin down why this is the case, but I suspect if we changed to using integers rather than single values, which I think they are, this will work. Okay, so let's kill this breakpoint, and var1. So what I'm going to do is I'm going to say how do we do it? Def int a I can't remember. There's something that would just say everything is an integer. It's a command I never really used much. The def int statement. Yeah. So def int, and then we go A to Z. Okay. What this means is a shorthand for saying, you know how the default use is always a variable is a single? Well, if you say this at the beginning of your program, def int A to Z, that means any variable starting with the letters A through Z is going to be an integer by default. And so var1 and var2 are now integers, even though we didn't put percent signs after them. So now this... Yes. Okay. As is the case for any inline function. So the reason that didn't work is because this is an inline function that returns... Oh, it's just overriding everything. We've declared this as an inline function earlier in the program, but this says, no, everything's a variable now. So, okay, we don't want to do that. Let's just say anything starting with the letter V for var1 and var2. So let's do it. Okay, now we can do subtraction. What? Okay. Yeah, print numstring. Print eval of numstring. Even though it's an integer. So what we're going to have to do, okay, so the problem with val is it returns a numeric value of a string of digits. That's it. And it doesn't tell us what kind of number it returns. Oh, crap. Okay, well, so to fix this, what we could say is this. If integer of val, but no, that's not going to work either. Because if it's 5.99999, then that will be 5. We need something that rounds up if it's rounds to the closest. What is cint? By rounding cint. Okay, so this is actually something that I've never used, but I've just discovered it now. It converts a numeric expression to an integer by rounding the fractional part, not simply truncating it. So let's do that. Cint. This should work. I should be able to get 1,000,000 points. And indeed, everything is working out fine. So that's the problem. Now, I suspect that on original hardware, this was not the case. It did not change 6s into 5.999 repeating just randomly. So I never encountered this as I was going to say as a child, as an 18-year-old punk. So this is where DOSBox failed us. Thank you, DOSBox. Okay, well, we figured it out. Thanks for joining me in this adventure in old code. Have a nice day, and we will see you next time.